Okay, guys, here we go for the very first time. I do apologize if I have any pauses, uhs, or likes, but we're currently really just rolling out this online method. So, college trigonometry. Some of the top students in the school, you guys have reached this far, and be aware, once again, this is a calculus preparation class. Much of what you do is just to develop your mathematical strengths, and not necessarily specifically will you be learning topics that directly relate to either calculus at the Calculus 1 level or maybe your future career. But no doubt about it, still is fun to learn. So today's agenda, we are going to visualize the relationship between the XY axis and the X prime Y prime axis. And of course, I'll explain to you what the X prime Y prime axis is shortly. And then we are going to develop rotation formulas to help us be able to connect the two. So if you want to think about it in a certain way, think of the XY axis as a particular language and the X prime Y prime axis as a different language. And obviously, you and I could describe the same exact situation, whether it's in the first language, we'll call it Spanish, or the second language, which we'll call English. You and I could definitely both look at a dog, and we could describe that particular dog using the appropriate language. Whether it's Pharaoh or it's dog, it's the same exact thing. So here we go. And once again, be flexible and be patient as we work our way through this. What do we know? In coordinate geometry. First of all, I'm going to apologize. I have yet to figure out how to get rid of this particular branding in the bottom right, but such is life. This is the XY axis. Obviously, this is the vertical axis. You've always called it Y. This is the horizontal axis. You called it X. You've been doing it probably since elementary school. And all it is a ability to connect geometry and algebra. It's called coordinate geometry. So any particular point P, and this is where it is, right there. By definition, is a certain distance from the origin. Origin, of course, is located at 0, 0. And bear with me as I work my way through handling the smartboard presentation. And I believe in trigonometry, you guys like to call the distance that this point is right there from the origin as the value of r. And I remind you, college trigonometry, we are going to use that relationship of right triangles and apply them at many different levels. So what do I know? I know that, excuse me, if I was to drop a perpendicular, and I'm going all the way back to geometry class, down to the horizontal axis, I've created that most important shape known as a right triangle. Right triangle has led to so many advancements in the modern world. It was worked on extensively in many civilizations previously, and maybe one day you'll take a history of math class and you will find it intriguing. By definition, the distance from here to there, which of course is along the x-axis, we refer to as this particular point P's x-coordinate. And then the vertical distance from here to there along the y-axis, we always correspond to this particular distance as y. So therefore, in the beginning of the year, you guys would have learned about sine, cosine, and tangent, secant, cosecant, and cotangent, and the relationship that the ratio comparisons, once again by division, of these values have to each other. Right triangle trigonometry. So this particular point P, there it is, can be expressed in terms of the horizontal distance from the origin and the vertical distance from the origin. And of course, being positive or negative simply relates to which direction I am moving and the 4 quadrants of the Cartesian plane anyways. It does not matter how I set this proof up, but we're going to do quadrant 1 just because that's what I have set up at this particular moment in time. So this is your language. It is the language of the X and the Y axis, your ability to plot points, your ability to identify distances and relate them in a meaningful way of expressing the location of a particular point P. Once again, I do apologize as much of this is rudimentary. Just bear with me as we roll our way through this. Because most kids in geometry are also following us, but all of a sudden we're going to take a drastic turn and we're going to use trigonometry. So let's say that I came along And I saw the same thing you saw. But of course, let me get this right, expand this out a little. I see it in my language, and my language is not the language of your language, which is the X and Y axis. Let's say that I wanted to take point P, there it is, and I wanted to express its location in terms of my coordinate system. And my coordinate system is slightly different than your coordinate system. Essentially, what I've done is I decided I wanted to take your x-axis and I wanted to rotate it. Look at that, rotation, rotation. And I'm just going to call the amount of angle I rotate is theta. But once again, I still have point P. And what I'll do, just for the heck of it, instead of calling my axis the x-axis, because clearly it is not, yours is the x-axis, I'm going to call mine the x prime axis. And instead of calling mine the y-axis, as clearly it is not yours, this is yours, it's the y-axis right there, I'm going to call mine the y prime axis. And of course, you guys do recognize prime notation is often used in the language of transformations, dilations, reflections, translations. I know my junior high kids were working on that at Preston earlier this week. So once again, math being math. I've made and written things close enough to confuse many of you. So just make sure at any point you hit pause and take an opportunity to really digest what is being told you here for you. So in summary, both you and I are looking at the exact same point. You have expressed it in terms of your horizontal and vertical movement. I am going to do the exact same thing. So once again, it does start with a right triangle. So I drop a perpendicular down from the point to my axis. Perpendicular, of course, is the key thing. It's right triangle trigonometry. According to this exact same logic, from here to there is still by definition the exact same value of r as it is from you, from here to there. That is r for you, it is r for me, and r is the exact same thing. However, what is not the same is the movement along the axes. Clearly you can see, and you should be able to visualize, that my particular movement is longer than your particular movement with respect to x. So I'm going to call mine x prime, because by definition still, the movement horizontally along the x prime axis corresponds to the x prime. And listen to that. That was my wife's phone going off. Let's ignore that. Same situation over here. This by definition is y prime, meaning the vertical distance along the y prime axis up into that point. And there it goes right there. So what you can see in actuality, that point P, it's that purple dot, has not changed for you nor me. It's never moved. What has changed, however, is the two languages to express the location. You express it in terms of x comma y. I, on the other hand, am now going to express in terms of x prime comma y prime. But since it's the same point, by definition, they must be the same thing. That's the power of that equal signs right here and what it means. What I don't know is how x comma y relates to x prime comma y prime. What I do know for a fact, however, is that when I take a look at this point P, I can express it like this, or I can express it like that, which means there must be some particular way to translate from this to that. And that, in essence, is going to be our challenge today. So I'm looking at this mess right here. And what I do notice a couple things is I did rotate my axes an amount of theta. What I do notice is that there's still rotational value from the x prime axis up to that r ray right there. So I'm actually going to label that as alpha. And then what you're going to notice is I'm looking at a bunch of right triangles. This is a right triangle. This is a right triangle. This is a right triangle. And this right here is a right triangle. I'm back to those really challenging problems in geometry. Though it is more applicable perhaps to physics, I would like to just point out for the record, by definition, this angle and that angle are the same. They are right angles. All right angles measure 90 degrees if we were doing a proof. This angle right here and that angle right there are the same. They are all vertical angles, and we know vertical angles are also always equal. So by definition, this value of theta is the exact same as that value of theta. Triangle sum theorem, all three angles in a triangle add up to 180 degrees, which means by definition, this little right triangle and this, I'm going to use the term medium-sized right triangle, are similar according to the angle-angle similarity. So if you had a good geometry teacher, you should be thankful to them right now. If you had a bad one, that is a bummer, but I showed you that, and we're not going to take that any further because we are heading in a different direction. So in summary, once again, we have figured out that we, if we wanted to, could rotate, grab my pen right here, this one right there, the x-axis, there it goes, a certain amount called theta, and create a whole new set of axes called the x prime axis. But whether I'm on the x or y axis or the x prime and y prime axis, I definitely could describe this point P. I now officially have two different languages of doing it, and it does go without saying that the amount of rotation at this point is a bit arbitrary. So what makes you guys better than geometry students and college algebra students is that you should be well versed in the joys and the opportunities that trigonometry gives to you. And once again, we are talking about right triangle trigonometry. The sine of any particular angle, we'll call this alpha, is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Of course, for you guys, way back, I believe in chapter 5, you would have recognized, oh, it has to do with coordinates, x and y, any particular value of r. So let us now move into a little more algebraically, an algebraic approach into looking at this particular diagram right here. So moving on to the next slide, and let's see what we got from this. What do I know? Okay, first of all, apparently I'm stating that the cosine of alpha is equal to x prime over r. Let me go back and make sure that is correct. Here is my right triangle. There is alpha. The cosine is equal to this adjacent side compared to that. So that is correct. I feel good about that. Let's look at the other one. The sine of alpha is equal to y prime over r. Once again, here is this right triangle. There is alpha. The sine is the opposite over the hypotenuse. I do feel good about that. What else do I know? Well, from that beautiful chapter of identities, apparently there is a ability to find the cosine value of the sum of two different angles. It's going to be theta plus alpha. So out of curiosity, I am looking at theta, which is this angle, and alpha. Okay, which means I'm really looking at this big right triangle right here. And by definition, the cosine of theta plus alpha is this adjacent side compared to this particular hypotenuse, which is r, which means apparently that is x over r. Okay, the sine of theta plus alpha, I recognize now I'm looking at this particular right triangle, which is this big one right here, where it is a right triangle. Theta and alpha is this entire angle right here, and sine is this side compared to that side. Interesting. So what I know is that the sine of theta plus alpha is y over r. What I would like you guys to see is that we're dealing with right triangles, and at the moment, what I'm seeing is r consistently showing up. I'm seeing particular angles showing up. And I noticed, however, that I'm working within two different systems. Look, I even color coordinated for you guys. Interesting. So what is alpha? Alpha is the angular rotation from the x prime axis up to this ray called r. What is theta? Theta is the amount of rotation from the x-axis to the x prime axis. So in essence, theta represents how much I rotated the axes. So theta seems to be going to play an important role with what we do. Now, just for the sake of typing, I'm going to, from now on, replace a theta with an A and an alpha with a B. And then at the very end, I'm going to go back and replace the theta symbol and the alpha symbol at this point. So let's work with this one right now. So if the cosine of alpha is equal to x prime, let me get some font here for you guys. That means that if I was to multiply both sides of the equation by r, I would lead to x prime is equal to r times the cosine. Instead of writing, once again, alpha, I'm going to write the letter b just because it's easy for me to type. So algebraic manipulation, it's a wonderful thing. So what do I have? I now have, at some point, been able to calculate exactly what x prime is. Well, I'm going to use that same sort of reasoning over here. I'm going to multiply r to both sides of the equation. Just for the record, once again, r can never be 0, and the point would not be moved from the origin, and we have no right triangle. So doing that, back to my typing, there we go. I'm good. I should get r times the sine of, now, once again, alpha will be letter B. I'm repeating myself, quite honestly, because it's going to probably help me out later on. I'm an old person. And once again, this is equal to y prime. And there we go. I now have the ability to calculate y prime and x prime as long as I somehow figure out exactly how much angle B is, which means how much is angle alpha. These, of course, are identities that you should have worked on in depth in chapter 6, maybe. I don't particularly remember. That's more of an issue with Mr. Kern. So if you need to review anything of that, but of course you should have them memorized. Well, here we go. So same situation. I'm going to use algebra, which is why college algebra was a great class. It taught you a process to derive answers, not so much a way to memorize something and get an answer. It is a process. So what I'll do is I'll multiply both sides of the equation by r. And here we go. That should end up with r times the cosine of theta, which will be angle A, plus alpha, which I'm now going to call angle B. And apparently this is going to be equal to x. And once again, whether I write equals x or I write x equals in front over here, it is not relevant to us. It means one and the same thing. Be flexible. So there we go. Interesting. All right. So what do I know? I definitely do know that this, and there's an identity for the cosine of the sum of two angles. So I'm going to keep working with this and see where it leads me. So here we go. Therefore, x is equal to r. I am going to use a big set of parentheses. And if I remember this identity correct, the cosine of the sum of two angles is the cosine of the first angle times the cosine of the second angle minus the sine of the first angle times the sine of the second angle. Obviously, there's more than one way to write that. But I remind you once again, if there's any issues, to take a look at a particular chapter and feel good about that. So now I'm to here. Went from here to there to there using algebra. And you know what? I recognize there's actually some more stuff to do here. So for that, I'm going to keep going. X is equal to, I think what I'm going to do is I'm going to distribute this r to the first term, and then I'm going to distribute r to the second term. I did have a college calculus teacher tell me that the distributive property is the most important property to understand all the way through any sort of education in mathematics. And of course, when I distribute r to this, I'm multiplying r to the entire term, not to each one of the values within the term. So not to each factor, but to the product itself. You would be amazed at how many kids still make that mistake. So here we go. And I'm going to write it any way I want to write it. So r times the cosine of b times the cosine of a minus, I'll try to leave a space here in the minus sign to make it a little more clear, r times the sine of b times the sine of a. And I know if I make any sort of calculation in this, I expect you guys to catch it at some point in time. That's why you're such good students. All right, interesting. So in summary, once again, identity, distributive property. What I notice is that r cosine of b shows up right here, and r sine of b shows up right here. So using substitution property, I'm going to keep going with this. So the x is equal to, so I'm going to replace r cosine of b with x prime. And I'm still left with this cosine of a minus, I'm going to replace r sine of b with y prime. And I'm still left with this sine of a. And because a is equal to theta, I think I'm going to spend the time right now and clean this whole thing up by writing x is equal to x prime times the cosine. Make my theta symbol. It's in here somewhere. I just have to find it. I'm guessing probably related to here. I'm wrong. There. Okay. There we go. There's theta. Hit theta. Hit insert. Nicely done by myself. I'm so proud of myself. Hit done. Minus y prime times the sine of, once again, angle A is theta. So let's replace it with a theta. Now I'm just going to copy and paste. Thank goodness for memorizing those commands on my keyboard. And okay, and I'm done. And many of you may be wondering, what exactly have you done here? Well, I'd like to show you once again, our challenge is we can use two different languages to discuss a point P. The issue is, how can one get from the language of x comma y to the language of x prime comma y prime? And apparently this right here is how we're going to do it. This is known as a rotation formula. X does relate to x prime and y prime. So apparently I can, anytime I see x, I can replace it with this right here. X prime and y prime correspond to x prime and y prime. So I'm talking now about my rotated axes. And theta, apparently, to be able to do this, I need to figure out exactly how much I am rotating the axes from x, y to x prime, comma, y prime. And at this point in time, the drums, the bell would ring. Everybody understands everything, and the world is better off because of it. I am not done, of course. I need to address this one right here. So I'm going to use the exact same process at this point in time. You guys could probably do it yourself. So I am just going to do the mathematics, and I'm going to trust that you yourself can follow along and justify each one of my steps. If you cannot, that's not a problem. You know I'm always going to help you guys anyways. So here we go. First thing I'll do is I will multiply both sides of the equation by r, and I'm going to get r times the sine of, I'm going to replace theta with an A and an alpha with a B. Nicely done. This, of course, is an identity for the sum of two angles, how to calculate its particular sine value. Since it's going to be an expression, I'm going to take r and use parentheses. That's not a parenthesis, of course. And I just need to remember what the identity is. The way I just remember it is the sine of the first times the cosine of the second. The sign between the two is the same, times the sine of the second times the cosine of the first. And I know many of you have memorized this certain different ways. Back in my day, here we go, I'll pretend like I'm an old person, we had every single one of these always memorized. At no point in time did we ever have a reference sheet, but you guys probably did have a reference sheet, or I don't particularly know. Next step, of course, was to distribute the r to both of those terms. Clearly, this is showing up again, so I'm going to associate the r to the ones that I want. So we have r times the cosine of angle B times the sine of angle A plus r times the sine of angle B times the cosine of angle A. I'm then going to recognize that I have substitution opportunities here. I'm going to now substitute, and I'm going to get y is equal to r cosine of B is simply x prime times the sine of angle A plus r sine of B is y prime times the cosine of angle A. And just like this one right here, I am now going to clean it up by taking angle A, replacing it back with angle theta to make it consistent with the earlier slide. I'm going to use the space to clean this up for you guys a little. X prime is equal to the sine of angle theta. So let's hit the theta symbol again, insert. Here we go, wrong command. Here we try this one. There I go. We find angle theta. There it is. Hit insert. Then this plus y prime times the cosine of angle theta. And I once again have the two things that matter. I have the ability to relate y to this whole language of x prime and y prime in a particular angle of rotation known as theta. Notice we use trigonometry, sine and cosine, to do that. So the two main ideas that you are taking out of this, without a doubt, is that you need to make sure that you have this right here and that right there understood, and most definitely somewhere in your notes. Pause for a second, and then what we're really talking about is if you look on your textbook, because this entire development of the idea can be found on page 673 in your textbook. It is essentially section 2 where it says use a rotation of axes to perform equations. You are just doing essentially the bottom half of that page. And somewhere in your notes, you need to fundamentally understand that if we were to take any particular point P in terms of x, comma y, clean that up a little, sorry, x comma y, we can magically enough, using trigonometry, take this and transform it into a particular point P, but I can now express in terms of x prime, comma, y prime. So let's get this up here. Let's make this nice and bold for you to make sure it's in your notes. Understand I'm doing something. That's what that arrow implies. And what exactly am I doing? I'm simply, just like our beginning analogy, changing languages to describe the same exact point P. And how am I doing that? Well, I'm doing it by rotating the axes through an angle of what I'm going to call now is theta. Go back to my symbol. Once again, this is just helping me get better at this, and just like you guys are. All right. So once again, let's make this all right. This can be done by somehow rotating through an angle of theta. Go all the way back to our diagram. Everything comes back to this particular diagram. Make sure you're clear about the diagram. And how am I going to do this? Well, I'm going to use my rotation formulas, where apparently x is equal to x prime times the cosine of, I'm going to type this out one more time so it gives you guys a chance to think about it. Obviously, the beauty of the video, you can fast forward through any teacher talking. It is quite nice, isn't it? X prime times the cosine of theta minus y prime times the sine of theta. Let's make this nice and big. So that's one rotation formula. Got to make sure I know it. And then the other rotation formula, if you don't mind me shortcutting all this, is not that, but rather to understand the concept of the y coordinate, it is going to be equal to x prime times the sine of theta minus plus, there we go, nice catch for myself, plus y prime times the cosine of theta. So there is no essential homework at all today, other than if you look on Google Classroom, as you of course might have seen when you clicked on this particular link, that I do ask you guys for some quick feedback and a chance for you to reflect and need to clarify, because I didn't have to answer a single one of your questions during this entire lecture. So on that note, have a great